So the factor number one, you are having sublimation, or you can call it atomization energy. So during sublimation or atomization, so we are having, let me say, zinc solid. We want to atomize it to zinc to go in gaseous state there. So it means when it goes in gaseous state, it's going to be easy for it to dissolve in solution and to give us the electrons, and we shall get electrode potential value there. So, but if you are having a higher value of sublimation energy, a higher value, it means it is very difficult to convert zinc, let me say, this solid to gaseous state. So it means we are going to have a less negative value for electrode potential. Let me say, if the element or the substance having more sublimation energy, it means the electrode potential is going to tend to positive. And when it tends to positive, there we shall say it is low electrode potential. But as it goes to negative values, it means we shall say that is high electrode potential values there. Because we are looking at the ease of these metal species to give us the electrons. Let me say, if you're having zinc solid and it gives us zinc ions plus 2 electrons, and the more the value gets to the negative, it means the reducing power of these elements increases. So let me say they become more reducing agents than oxidizing agents. So let's look at another factor, is ionization energy. And ionization energy, the higher the value of ionization energy, so the less negative electrode potential value we shall have. Because it means, if this is the metal, let me say this is sodium. Sodium is there, and sodium is having also the electrons. So I'm representing the inner core. So it means there is a lot of force attraction, nuclear charge, which is there between the protons and the electron. Let me say that this attraction cannot be easily broken. So it means the electrons cannot easily go away from the metal species here, and it means the electrode potential value is going to be low. But if you are having low ionization energy, let me say, like for example in group 1 in the periodic table, so the species there, they are having low ionization energy. So it is very easy for them to give us the electrons there. So it means they are having less ionization energy, and they are going to have a higher value of negative electrode potential. Let me say they are going to be more reducing agents. Another factor is hydration energy. And hydration energy, we are looking at how we can surround, let me say, a compound infinitely with, let me say, to surround, let me say, this positive with water molecules there, and is surrounded with water molecules. So the higher the hydration energy, it means the higher the negative electron, because it means it's very easy to surround the gaseous ion with water. And when we surround it with water, it means it is dissolving. And when it dissolves, it will give us the ions, and it's going to give us the electrons there. It can be any form of electrons. And remember, the hydration energy is always negative for most ionic species there. So let's look at concentration. So concentration, let me say, if you're having 0.1 molar copper 2 sulfate and 0.4 molar copper 2 sulfate. So we shall ascertain that this solution, which is 0.1 molar, is going to be, which is lower than this, it's going to have a more negative value of electrode potential than this, because whenever we increase concentration, when concentration increases, it means you are decreasing the rate of ionization. Why ionization? In this case, this ionization is not like the ionization energy. We are looking at is how the species are going to go into solution in that case. So it means when ionization decreases, it means there is some influence. The influence comes from water. So remember, when you are having more concentrated solution, it means the solution contains the little water. And when there is little water, it means the species, let me say, the solids, let me say zinc, it will not ionize. Let me say there is little water which can react with this zinc to dissolve it. So we can conclude and say the higher the concentration, so the less the less negative electrode potential.